So good morning, friends, colleagues. Thank you many for the nice and warm words. I'm so proud of you and other students and also the children and grandchildren that exist here. Yes. So I am going to talk and try to give the background, but also some thoughts for the future regarding the Israeli research. And you have heard already some lectures, and I'll try to put some things together. I also give some knowledge about the research going on in Israel. Some of it I may not get too much in depth. It is on the slides that you would be able to see. So now I hope I learned how to switch those things. Not this one, not this one. What is yeah, there are two greens, so the direction should be here. So what I'll be talking is about the Israel's holistic water cycle. This is the way I see it. We'll talk about the challenges that we have in front of us, topics that are going on in the last years. I also show the main academic institution, the governmental institutes that support, and a little bit about financing, but also somewhat about new thinking about the water standards. So if we look at Israel, which is a small country, but is one of the fastest growing country in population, the last census on the 31st of December 2023 showed a population of 9,842,000 people. So it's not a big country. The area is not very big, but the speed or the rate of population growth is the number one which dictates the need for water, together with the level of living, which became higher and higher, more or less like in the southern European countries, and a lot of things that happen, fortunately, but a lot of unfortunately. So because of the growth of population and the need for water, growing water, there was no other choice for Israel but to look ahead and start manufacture water. So we have a big water manufacturing factory, which is the most contributor to it. It started with water reuse. The Shafdan, which is the largest source of wastewater for irrigation, started around the end of the 70s. And a lot of many hundreds and hundreds of small projects like in different regions, different areas for water reuse. Also in the cities, urban water reuse has been developing, like in my town, Herzliya. There is a very nice park which is irrigated with the reused water, and so in other cities around Israel. There was a lot of marketing of water conservation, mainly at home, behavior of people. Water conservation found itself very efficient in Israel. A lot of small apparatus that you use in showers and in the toilet and other places at home. But if you take in total the amount that is being conserved or could be conserved, is not more than one big desalination plant, for example, but still the culture is being kept very, very nicely. Other things like using rainwater harvesting and rain enhancement take place. Harvesting is not yet developed enough in Israel, but now we can see some cities that are trying to do that. Harvest, like Ramat Gan, is taking the floodwater and is going with some treatment to introduce it into the ground and keep it subsurface for having more water storage for days to come. There are also plenty of innovations, like from taking water from the air, using different brines, even different types of sludges. But I would say most of the extra water come from desalination. Like you can see here, desalination water reuse. You can see Ashkelon plant was the first one that started to work around 2004 or 5, and not very far from there is a brackish water plant. There are several, only very few of plants like this, but again, as you can see here in the conference, there is work going on to get more and more brackish water desalination inland. This is the map of Israel. I know that many of you have visited Israel. What you can see on the east is the Jordan River, which actually, in the beginning, it begins far in Lebanon, but you see the Lake of Galilee in the north, and then the Dead Sea in the south. Between them, there's supposed to be a very alive river, but the farmers are stealing the water from both sides, from Israel and from Jordan, and there's not a real river, a Jordan River, only in poems yet. Now you can see also the what you see in red are different projects which reuse wastewater. The largest one is where is that? So I don't know. I don't see. But Tel Aviv is here, and the project of Shafdan starts from here. It collects the water from a population of about 2.5 million people, Tel Aviv and the satellite cities, and takes us down about 100 kilometers down for a large area of irrigation. Around Haifa in the north, there's also a project which is much smaller, but still reusing Haifa and the Bay wastewater. And also Jerusalem, there is a reuse of some of the water to the east and some to the west. Near Beersheba, which is in the middle of the Negev, the south part of Israel, you can see it here actually, down to Eilat. There are different projects, but relatively small size. But I would say that the whole country is kind of covered with a lot of small to a little big wastewater treatment plants. In total, about half of the agriculture in Israel is being irrigated with wastewater, 50%, which make like around 1 billion cubic meters per year for agricultural purposes. It is the total, so this is about half of it, around 500,000 cubic meters per year of wastewater. The other big source, as I said, is desalination. And what I put here on the map are the different desalination plants, where the southern one is Ashkelon. Where is this? From here. This is Ashkelon. It was the first one, the most popular in literature, and then others like Ashdod, Balmachim. In Soret, there are already two plants, Hadera plant, and this one is, I think, it still is not ready. The total potential of installed, or maybe in another 1 or 2 years, will be 940 million cubic meters per year. Not every year it is necessary to use it. There is an agreement between the government and the private entities who built and operate these plants. There are contracts of 25 years of operation, and then government might renew contract, might change the owners, but this is the way it works. Without the private business, private companies, private investments, there wouldn't be a solution in Israel to the water, and this is why we should appreciate a lot the companies that put their money in, and because of that we have drinking water. So about, I'm not familiar now what is the exact percentage from drinking water, but it goes probably around the 65% or going up to 70%. Most of it comes from the sea. Something close to 90 million, I've been told in the break, goes from brackish water. But there are plans to enlarge it. So this is a picture and of the background and the advancement of water treatment needs in Israel, because all this type of water, they need a treatment, I guess, everywhere in the advanced countries. And I would say that one big change was in the flow direction of the national water carrier. Actually, the center of gravity of water supply changed from the north of Israel to the middle of Israel, or it's almost in the south, because of these large desalination plants that have been already enlarged from their first capacity. So the water flow had to change direction in large part of the national water carrier. Today, actually, in the past, before the desalination started, most of the drinking water came about 2/3 from groundwater and about 1/3 from the Lake of Galilee, some surface water. Today, only the Galilee in the north gets water from the Lake of Galilee. Now, if we look now at the whole picture of what is going on in Israel, I think the best thing to do, and not only in Israel, would to look in a holistic manner when we use, when we plan, when we invest in the water. There are actually two cycles here. On the left hand, we have the inflow of water or production of water from rain, from desalination plants, there are some two big projects of surface water collection and injection, groundwater, industrial water, not too much, but they still exist. And the reused water, and all together, they give the picture of the main water sources in Israel. On the other hand, you have the contribution of wastewater, which most of it is being treated for reuse in a pretty good level. So, but we can see immediately in this picture that all of it is getting together. I mean, wastewater are being used for irrigation. Some of the water gets into the environment, into the ground. Many smaller reservoirs get both wastewater and rainwater. And the fate of the water is sometimes unclear, but there is quite of involvement of all types of water in the water arena of Israel. So we must look, I would say, at the Israeli system today, not as a different departments or projects or types of water, but to look at the whole picture together and make then the management and the balance between all of them. Now, there are different contaminants in the water, similar to what you have here in the United States, and I don't need to go over everyone, but there is a lot of care, I would say, about the water quality. Today, some of the issues are being brought here, would be like inorganic contaminants. There are traces of medicines that are getting, or hormones that are getting into vegetables, for example, very low quantities, but it's being investigated. The PFAS is being investigated. They're found in several spots in Israel. And all the rest, the biology, and I think it is quite similar to what you have in the United States. Now, another subject that is very, very important in Israel is water security. And this has been taken care of in the last years. There are a lot of attacks from Iran and sometimes from Russian sources on Israeli treatment plants. And in the United States, you also have a lot of them. I looked at this topic too. And today, there is a special care on the topic of security. And this also becomes a part in the management of the water in Israel, an integral part of it. Now, starting to talk about quality, one thing that has been raised yesterday, and we had a very nice discussion, was the lack of magnesium and calcium in desalinated water. I mentioned it, but not talked about it too much, but there has been investigation and research which showed that there is not enough supply of magnesium and calcium. In fact, even before the desalination started in Israel, the calcium level intended for health was lower than at least the WHO has recommended. And this is a problem that is taking time to solve because different obstacles, mainly money and I would say conservatism. Another thing that I would like to point out, and also relates to the climate change, I would say, that in these years, climate change can be very quick and fast and unpredictable. We are in an era of uncertainty. And for example, this is a case where there was a big drought in Israel, and there was not enough water for irrigation in the north of the Negev. So there was no other choice but irrigate with desalinated water that came from the water desalination plant in Ashkelon. And then there was quite a damage to many food plants. You can see it here. Leaves got yellow. Some plants stopped growing, and created a deficiency in calcium, magnesium, sulfate, things that are very necessary for food, for plants to grow. Another thing that was taking care of it is the boron, and the government set a very, very low limiting concentration for boron, like 0.5 milligrams per liter, which had to make amendments in the design of the treatment of the desalination plants, and while the first price of water from Ashkelon desalination plant was a big economic competition between companies, Spanish, Israeli, Chinese, and it came up like 48 cents per cubic meter was in the beginning, but because of boron, they had to add another 15 cents per cubic meter in order to prevent boron from getting into the water cycle and getting into the plants, the soil and the plants. This thing takes too long, in my opinion, to fix, but it should be fixed. And Israel actually is the first country in the world that put introduction of magnesium into the standards, not yet enforced, but it's there, and have pilot plants now. One of them was mentioned in Magan Michael, that is trying to come up with a real price for reintroducing magnesium into our water. This is a planned scheme of one of the cycles that we see, and in the salination, and you can see that from the sea, the water is desalinated, get mostly to urban use, but after using it, it gets to the wastewater system, and then it goes to the wastewater treatment plant. There is not any addition of magnesium, not at home, and not in the wastewater treatment plant. And it goes for irrigation. The plants don't receive the magnesium. Then, of course, part of the water evaporate, part go into the ground, and part go for food, which lacks magnesium, and then this is a kind of internal cycle that happens. Now, to get a solution for it, borne is removed. Remineralization happens at the water that's coming out of the desalination plant. It goes to calcite stone to give calcium enough to protect the pipes from corrosion, and it's also a good addition for the human body. There are limits, but no, actually the pH is being amended, and then it goes without any addition of that the body of the man, our pipes in the body need. Yeah, I will say one word about monitoring. I didn't see much about monitoring in this symposium, but there is a lot of smart monitoring devices that have been developed in Israel. They are being used also in the United States, all over the world, and it is very helpful in order to manage such a very complicated system. Now, I think we already saw the importance of water quality in this whole cycle. Actually, is the regulation, the standards that today dominate the management of water supply and wastewater reuse. And this is because, we have solutions, not in any country. In Israel, the sea is, I would say, like an endless source of water. Wastewater, there's always, and it's growing, population is growing, but the quality is dominating today, which is a very, very big difference from the last century. In the last decade, the several amendments and advancement of regulation have been set up. Water quality for understated irrigation, wastewater quality to disposal for streams, industrial effluent quality, drinking water quality, and desalinated water quality. And there are, I would say, continuously standards that are being used for materials and equipment. Mostly this is more under the Israeli drinking water standards. I am happen to be chairman of both the drinking water standards. And I'm chairing last year's the main water committee in the Israel Institute of Standards, and also the Ministry of Health, of course, is being involved, and we are trying to bridge between these two areas. However, I would think if we look at in a holistic way, some people call it now one water actually relates more to quantity. What I think is a must to get together and start to think and start to make change, think out of the box, is one water quality standards. I mean like the regulation or standards of water will be under one umbrella, as you can see here. Because also in my own experience, sitting on all those committees, and also in symposium like this, and working on my own research, I could see the overlapping of all those water or effluent resources. There's a big overlapping, both also in the thinking when you start to make a standard, because you always have to think today, okay, I'm making a drinking water standards, but I know that some of those elements can reach back the environment, the food that we are eating, and vice versa. So this is something which is very, very important, particularly in this time of climate change, because climate change happens, no matter what the reason is right now, yes? Climate change happens, and what we saw before, when there was a drought, and the desalinated water had to be directed for irrigation, nobody foresaw it. There was no any preparation of some kind of adjustment of the water quality. And this is one of the reasons that we have to put our mind together and look at how we can make a change in the way we look at standards, because standards are a major driving force in the development of a water industry, and it should be more into our mind, and we should more teach in schools about the standards, which I don't think is done enough. So now if we go into research areas that Israel is doing, you already saw that a lot of research is being done in the big relationship with the pictures that I showed you right now. So I tried to list the lot of areas. Many or most of them are known also in the US and Europe. Is there different types of water treatment, physical, chemical, biological, advanced desalination technologies, a lot towards saving energy, or what to do with the brine by the sea, inland, different types of wastewater treatment. We talked yesterday about the soil aquifer treatment. We talked about misfortune that Israel becomes more and more dense population, and this area is needed. So how can we use effectively this type of treatment? Nanotechnology also is entered quite deeply into the water arena, but has a much more space for smart technologies to help in having a better, more efficient use of the system, reduce energy, reuse energy that is embedded in the water supply, using the flow in the pipe for energy, like one development of using making electricity in the meters, water meters, putting there also some energy because of the flow that goes into, and others. Post-treatment of desalination, we gave a lot of research has been done and is been done on the pre-treatment, but what about the post-treatment, looking at what we really need in this water. Now, I would like to come back now, after saying that, back to the thinking of the united standards, because again, the previous, I would say, thinking or economical thinking about having certain water directed to the easiest user, yes, you have less treatment, you put less money in doing that, is passé. Because we've seen a lot of examples already, things that happen because of climate change, that we have to take uncertain decisions today and not to wait until things happen and then we know, oh, why we'll not direct the water or treat the water differently. So grey water has been also researched in Israel, and I think there is we are encompassing all what can be in water to treat it or try to treat it properly and have standards assigned to it. Now, Minister of Science assisted me in getting more information. Although I'm sitting here and there on some committees, but to look at the whole picture, each year or a couple of years, depending on the grant, there are calls for research proposals. We can see, I would say, some of the best for scientists proposals are given in a program of national infrastructure. It's good, mostly good for young researchers, but also for everybody. And then there are binational programs. With the US, we have, maybe I'll go to the next slide. I'll show it later, but in the US, with the US, there are several funds, including the binational Israel-US grant, and the agricultural fund, just forgot the name, BARD, and there's also BEARD with the industry. There are several ways, and there are also possibilities to apply for grants from other associations. Like I participated in two investigations that with people from Berkeley and from other Texas and others by getting grants from the Water Reuse Association. So there are a lot of resources that one can follow. Now, the main institution, there's a lot of research going on in different places, but the main institution performing water treatment are, of course, the big universities like the Technion, Ben Gurion, Hebrew University, Tel Aviv University, the Weizmann Institute, not too much, but they do. Then Volcani Institute of Research, Tel Hai College, which now stops working. Kinneret College has been developing quite nicely, and Mekorot, the National Water Company, also funds research, mostly very, very applied research. Now, financing also has changed since the time that financing had to go into the desalination plants. and because of the high-tech research development in high-tech concerning water, there is more and more private funding coming into Israel to support innovation mainly, and so there are different joint venture incubators, there are governmental incubators, there are some industry that has their own incubator developed, agreements that I said before, and also some fundings from some internal institutions. I would say that funding is there to whoever has a good proposal, not always big funding. I didn't mention specifically, for example, the Water Authority of Israel, they are funding also research, but a very small amount, like up to 6 million Israeli shekels a year or something of this sort. So but it helps researchers start something or develop something else. So now the state institutions that support research, on top is the Ministry of Treasury. In Israel, Ministry of Treasury controls the money in every corner, and also influences a lot also the policy, and not gives only money. Instead of that, I would say the main institute is that are involved or support. Actually, Ministry of Science is one of the biggest supporters. Mekorot is a big supporter. The other offices, as also a Ministry of Health, mainly support the medical aspects. It doesn't have direct money for things that we are doing here, for example, but it has some collaboration with other offices that would give the money to them. Now there's a table here. I don't like big tables myself, but I also put it here so you will have it. And there's a list of different binational and international funding sources. UK, Canada, Europe, of course, the US, France, Germany, also India. A lot of research has been developing with India in the last years. Canada, also with Singapore, Japan, and so forth. So there is a lot of field area for collaboration with different countries, which our researchers really need this collaboration with countries that are out of our region. This meeting, of course, is one of the biggest contributions to having binational research. Here I give you, I will not start to read here. It looks quite small, but I got this from the Israeli Ministry of, now they call it Innovation, Science and Technology. I put here in colors, like the yellow colors are for water use, the black colors are investigations on desalination. Some of you here will recognize those investigations. I didn't put the names of the researchers here because I didn't have time to ask everybody whether I can put his name or not. But the information is available. I have to conclude now, I think. So, in my conclusions, I would put a finger on what I already said before, that we have major resources that are we call it artificial. Okay, water is nature, but artificial water resources become more and more dominating. The water quantity, I hope I could convince, is the major dominating area that controls decision making also over the quantity allocation. We have to look in a holistic way, in a kind of one water, as some people call it, on the system, on the water system, water using cycle. And in such a way, we have to look at the regulation, the standards, and try to work out and get the holistic picture, the holistic management being complete. And for this, there is plenty of room and a lot of responsibility, I would say, on us, the scientists, to get in there and to make the water more available and healthier to the population, both in our countries and on the planet. And in this case, public-private partnership has become more and more important. In Israel, it was a more socialistic country. In the United States, it goes without saying, but this is very, very important to develop. I would like to. Why it's not changing? I have a red line, but I wanted to show acknowledgement. Can I show another 2 slides? It's there. So I really have a deep gratitude to, again, I don't know, my ex-students, Moshe Ben Sasson, some of you may know him, that is now working in the Ministry of Innovation, Science and Technology, in charge of the office of this type of research, and also to Avidom, which is the chief scientist of the ministry, who allowed me actually very quickly. He said, yes, go on and show and talk about it. They are all for collaboration. And with this, I would like to thank you for listening. I know I was a little sleepy, but I hope something I could get across. Thank you very much.
Avner, thank you so much for that overview. It really helped to clarify the range of different opportunities and challenges that exist. I think a big difference, I'm particularly interested in agricultural water treatment and reuse, certainly a big challenge in California and in the middle of the US, where we have a rapidly depleting Ogallala aquifer. And I think one of the very, very big differences to start with is the ownership structure of water between the U.S. and Israel. In Israel, the idea that the state owns all of the water is in stark contrast to the patchwork ownership structure that we have over water resources in the U.S. I'm curious both what the history of that is and whether there was a transition at some point to the state owning it. I'm not sure if you can comment on that. But then I also have a second question about SAR values and salinization of agricultural lands and whether that's a challenge.
First question was about ownership of the water. Yes.
different than the US.
So in Israel, from I think 1958, few years after the independence, there has been a decision that the water belongs to the people. It's not that you dig a hole in the ground and you can pump water as much as you want. So you can dig a hole, of course, but you cannot take water unless you got a permit from the water authority, allocated such amount of water. If you take too much, you pay a lot of money, and they may close your water well, for example. This is not what happened, for example, in northern Italy, where they make the nice tiles and have a great food done there. And there was a case already, I think it was maybe in the end of the 80s or something like that, that suddenly those industries wanted to pump water, but the level of groundwater was too low. So they had to build a dam on a river and then to start using water from river water. But in the constitution and the regulation until today, they still are not, do not understand that this should not be the way how to control the water. So I think Israel can be an example for other countries for this way, because I think it's very, very good, very important. What was the other question?
The second question was the desalinated water and the sodium absorption ratio, SAR.
Yeah,
If there are any
yeah,
issues,
yeah.
you know,
Of course, there is an issue, and SAR went up to more than 5 when it was irrigated with desalinated water. So soil adsorption ratio, yes. So this is one of the indicators that you must change, look differently at your water supply content and what you take to the plant. That's a very good question.
David?
Yeah, so thank you very much for the presentation. It's really clear from seeing the presentation and from the talks we've had yesterday and that we'll have today that the engineers call the shots when it comes to research on water in Israel, and I think that's led to some great innovation. But, and here's the critical part, it seems that when engineers set the research agenda, the tendency to look at health risks and problems is a little lower. And so I think of the example of PFAS exposure, where it almost feels like people didn't want to know. When I was there a few years ago, I asked people, well, where's the PFAS in the agricultural produce or in this recycled water? And people said, no one wants to know. And when I said, well, what about leaching of lead from this aggressive water? And people say, well, we don't talk about that. And so how do researchers, what's the responsibility of engineers as researchers, and how does the country change this balance a little bit to assure that large mistakes aren't made when engineers enthusiastically embrace new technologies? How do you get the possible risks associated with new water supplies to be studied when your sponsors are the water company and the people who want to sell the products?
Yeah, all the best questions are being asked here. I don't know, maybe I'm too much involved with what is being done also by the government. But I would say there are several ways. Okay, the one way is, okay, thing happen and then you go to solve it and then you learn and then you take the conclusions and make your management better. Yes, like it happened in the Northern Galilee where they started to provide the desalinated water in the Low Galilee. All the people the next day started to phone the Ministry of Health, we have red water. And it took some time even to understand the Ministry of Health, this red water comes because of the desalinated water. Although scientists were talking about it, and there was pilot plans by Mekorot, by the water company, it happened. Now, but just think, if you wanted to be prepared for it, what would they do for hundreds or thousands of kilometers of old pipes? It's not very easy to solve it, but at least, first of all, to have this preparedness. Now, today there are some water suppliers that let innovators come and try what they do on their systems. Like, for example, the Jerusalem water supply company, they let an Israeli group to come and put a device that would monitor some of the water constituents, particularly chlorine, of course, but some others too, pH others. They made kind of a basic study, or they had those basic lines of the right concentration, and then when you have a jump, you know there is a problem there. And from that developed a very nice company that also is doing it in the United States and other countries. Yes, please.
But I think you missed my point a little bit. For example, in Singapore, when they implemented New Water, they brought in an international panel to do oversight and find potential blind spots that came from having engineers running a water system. And in the US, we have kind of scientists get rewarded for identifying possible problems. They get covered in the newspaper and they get grants, and that's like, it's the US system's different. We have people studying microplastics in drinking water now, yes, and identifying problems and getting rewarded. And my sense is that in Israel, there's a tendency not to want to anticipate these problems because it could get in the way of a national project.
I have to comment on that. Unfortunately, I understood that, that it was...
I don't think we have a lot of time.
No.
Maybe just you...
It's good, it's good.
I have to comment very quickly. Very quickly, and I'll pass the torch to Adi for 2 seconds. But overall, unfortunately, I'm not an engineer, just a microbiologist. But we have a very active water community that tends to give a lot of criticism for water companies as well as the government in terms of politics and how to manage water. For example, PFAS, I would not say a word because this is Adi's turf, but overall, this is a very, very active community of scientists that put a lot of emphasis on the environment and the ecosystem with the public.
Yes.
So,
I just want to one last sentence, and it's we'll talk about it more in length. But I also have to say that there's an interplay between producing water, which is the water authority, and making sure that the water gets to the people. But the water quality is governed by the Ministry of Health. And that tension there also really helps with the regulation because it's not the same people, but they do work together a lot. So there's three ministries that are in charge. There's the water authorities, there's the Ministry of Health, and then there's the Environmental Protection Agency or ministry, and together they have an multi-departmental panel that takes care of that, and also there's a lot of scientists chiming in all the time.
So I think we will stop now at this really. I mean, except you think I just want to comment again. In the United States, we are still using Victorian technology, sand filtration, calibration, and the US are much more conservative than Israel and Egypt and so on. But that's not going to be discussed today. Let's move on to the next section by Adin and Inez will chair. So, but thank you for starting this war.